Okay, class, good morning. This is Paul DeStefano, and we are in week 6, believe it or not. Only 2 weeks to go after this. This week we are learning service facility location. It is module 6, but it is chapter 8 of the book, as I'm sure you already know. And I wanted to go through the example problems that were given in the module. The first one is not representative of what's in the weekly assignment, but the second example question is. But in order to learn the material and understand it, I wanted to go through both example problems with you. So problem 8-4 in the text discusses a pizza delivery service that would like to open a branch near off-campus student housing. And they have 5 different locations that they're considering. And if you look here, you'll see the XY coordinates for each location. So X is 1, Y is 2, X is 2, Y is 6, and then down to C5, which is X is 4, or X is 5 and Y is 4. So those are the 5 potential locations that they need to decide which area would be the best. Now, the expected demand is what is really going to be a deciding factor in the math for this problem. So, although it's given to us as the demand at location 1 is 5, location 2 is W, or 4, location 3 is 3, location 4 is 1, and location 5 is 5. Now, these are not arbitrary numbers, because if you do this problem and you were to change those numbers, you get drastically different answers. That means there needs to be some market analysis done that determines what the demand would be in those different locations. And that would, using this cross-median calculation, you'll get the best location possible based on the proximity to the highest population areas, and that's where the demand is essentially coming from. So let's get started into the problem. So step 1 is to determine the median demand point. So if you have demands of 5, 4, 3, 1, and 5, that's a total of 18. So the midpoint of that is 9. It's not really the median as you think of a median where you have an equal number higher and lower. It's more of the midpoint of a total demand of 18. So we get 9. Next thing we do is we plot the 5 apartment complexes on a grid. Now this isn't, again, this isn't where the restaurant would be located. These are where the apartment complexes are located that need to be served. So the intention here is to open up one pizza restaurant that'll best serve these 5 apartment complexes with these 5 demands based on the population of those apartment complexes. So the next thing we do is create this table of complex 1 through 5 with its x coordinate 1, 2, 3, 4, 5. They just happen to be in order by coincidence. They would not necessarily need to be in order, but based on the speculation of the 5 locations, the x coordinates are in order. And then, of course, the weighted number is 5, 4, 3, 1, 2, as you'll see here, 5, 4, 3, 1, 5, I'm sorry, not 2. And they are also in order purely by coincidence. Now we go down and we go from right to left. And let me show you something what that means. When you plot, let me bring it up on this side. When you plot those locations for C1, complex 1, X is 1, Y is 2. And then for C2, X is 2, Y is 6. And for C3, X is 3, Y is 3. C4, X is 4, Y is 1. And for C5, X is 5 and Y is 4. So those are the 5 apartment complexes. So what this means is by going from right to left, you basically going right from 0, 0, going right, you basically come across until you get to each apartment complex, and you get to C1 first, then C2, then C3, then C4, and then C5. Again, purely coincidence that they happen to be in order. So on this column, we're looking at the cumulative demand of each location. So you get 5 for the first one. Then you add 4 and you get 9. Now, as soon as you get to that median point, you stop. They show 12, 13, 18, cumulative of all these numbers, but you stop when you get to that demand midpoint. Then you go left from out here, as far out on the grid as you can get, and you get 5, 4, 3, 2, and 1. And if you look at that backwards, you're basically starting with 18, 13, 9, 6, and 5. Well, when you get to 9, you stop, because either you're going to be equal to or greater than the demand. And in this case, there's 2 different locations. There's C2 and C3, with x equals 2 and x equals 3. So what they did was they ran a vertical line at x equals 2 and x equals 3. So that defines the x-axis of the area that would best serve all 5 apartment complexes. So then we come down and we do the same thing for y. For y, we have C4, 1, 3, 5, and 2. See, they're not in order in this case because the weighting is 1, 5, 3, 5, 4 for C4, 1, 3. So this is because on the y-axis, you're starting from down here and you're going up the y-axis. So the first one you get to up the y-axis is C4, then C1, then C3, then C5, and then C2. That's where this order comes from. And then the y numbers for those are 1, 2, 3, 4, and 6. 1, 2, 3, 4, and 6. And then, of course, you pull the demand weighting based on C4, 1, 3, 5, and 2. So then you're going up the scale from the 0, y equals 0. And you're cumulatively coming across each y number, and you're adding the weighting as you go. So you're going to get to this one first, which is a 1, and then a 2, and then a 3, and a 4, and a 6. And the w numbers as you're going up will be 1 plus 5 is 6, plus 3 is 9, plus 5 is 14, plus 4 is 18. You got to the weighted midpoint at C3, where y was equal 3. And then when you went from top down, the opposite, 18, 17, 12, 9, and 4, as you're subtracting off weighting numbers, you're going to hit the midpoint at C5. So basically your y numbers for the midpoint or higher is 3 and 4. I hope this makes sense. So if you need to go through it slower, just listen to it more than once. But y equals 3 and y equals 4 basically is where you drew the 3 for the lower y limit and 4 for the upper y limit. And what this basically says is that the pizza restaurant location, if your weighting is accurate based on the population of each apartment complex, would be somewhere in this grid right here. And on a map, that grid would obviously have streets associated with it and an area that you would decide what is best based on other service location factors such as access, traffic, parking, more of the aesthetics involved for where you would want to open up the pizza place in the best spot. So I hope that helps, and if you have any questions, feel free to ask. I know sometimes it gets confusing when I go through these, but I hope to give you as much information as possible if you ever determine that you want to use this cross-median weighted method of deciding where the best place to open up a service would be. Thank you, and I will now go to the next practice problem, which is represented as a question in the weekly assignment. Thank you. So here is problem 8-11 for Module 6. And I'd like to say one thing before I go into this example is that I went back and listened to my video for the previous problem. And at the beginning I said there were 5 potential pizza restaurant locations to serve the community, and then I changed it based on the homework assignment where it was 5 different apartment complexes and where they're picking out one pizza store location. So I apologize that I was contradicting myself in there. The actual problem is correct as I stated during the description, where there's 5 different apartment complexes with students and they want to open up one restaurant that best serves all 5 and not the opposite. So I apologize. So now let's go into problem 8-11, which is the set covering method of determining the best locations. So here there are 7 potential ATM machines based on 8 or 7 different communities, and they want the travel time to be within 20 minutes of any community based on which one they might open the ATM machine in. So the first thing to do is you have to look at from location 1, what other communities can be served within 20 minutes. So yeah, 2 can be served because it's 15 minutes. 5 can't be served because that would be a total of 35 minutes. 3 can be served. And of course 1, because that's in the community itself. So that means from location 1, 1, 2, and 3 can be served. From location 2, 1 can be served. 2 can be served, of course. 4 can be served in 20 minutes. And 5 can be served in 20 minutes. If you went anywhere beyond that, you'd be at 35 or 40 or 35. So it's not that I stopped at the first location I got to from that point. It's because when you go any further than that, you're over 20 minutes. So then going down the line, you go down to all 7 locations, and number 7 can basically serve 4 and 7 because 25 greater than 20, 35 greater than 20. So that is a map of all locations and the communities that can be reached within 20 minutes. So now how do you decide which location is best to get everywhere within 20 minutes? And can you even do it with just one ATM machine would be the question. Next thing we do is we eliminate site 7 because 4 and 7 is basically redundant with site 4, which is 2, 3, 4, 6, 7. So you would never do 4 and 7 both because 7 doesn't add any value to you, because 4 and 7 is a subset of 2, 3, 4, 6, and 7. So you eliminate number 7 right off the bat. Okay, so we scroll down. We've gotten rid of 7, so we only have these 6 potential. And then, of course, we see that site 4 must be selected since site 7 can only be served from there. So you notice 7 is not included in any other site potential. So if your goal is to serve every location within 20 minutes, every community, you have to do number 4, or you will not get community 7 supported. Then you manually scan down through the communities that can be reached within 20 minutes. And you realize that if you were to pick sites 2 and 4, 4 would get you 7, but 4 also gets you 2, 3, 4, and 6. And 2 gets you 1, 2, and 5. So if you notice, if you took 2 and 4 with all the communities it serves, it basically covers everything. There's no other communities missing. So the goal can be met to reach any of those communities within 20 minutes from site 2 and 4. So I hope that helps with how you will solve the assignment problem that has to be submitted by Sunday. And if you have any questions, holler, and I'd be glad to help you. So make sure you get your assignments in on time, so you can get the maximum amount of credit for your work. Thank you. Bye.